Alright, so I ordered some stuff from Elmor's lab for liquid nitrogen overclocking. I just wanted to go through some of it and give it a once over, see how it works. So here is the EVC2 SE in a bag. I need to open it. This is awkward. So this is a little USB controller, which has a couple I2C plugs on it, and what else is that? Some other connectors. Oh, I think that's just more I2C. VMod 1, it says a UART connector. Ground, MISOM OCS clock. I assume that's a connector to flash the microcontroller. I don't know. And there's another I2C connector. It's not like there's a manual in the box, so I guess I would need to find that out online. But it also comes with some right angle headers and a bunch of jumper cables and this 3D printed case that you can just plop, 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 plop it in, plop it, plop it, there, plop it in. So that exists, and I also got the heated backplate for motherboards, which has these 4 heating zones, and it says it can do 288 watts total, and the use case for this would be preventing condensation and minimizing the area of the motherboard that you have to insulate. So this cable plugs in there. Not my favorite type of cable. By far. But it goes in there eventually. And there's that. But this doesn't plug into here. That ain't gonna fit. So and you're not gonna get 280 watts through USB-C either. There is another component to all of this, which I have not looked at yet. It's this thingy, which is the HOT300 controller, which comes with this. Yeah, so you've got your I2C, your thing that goes to the back plate, and your 6-pin power, so you can get power. So I'll plug that in. And then I will... Oh, it also comes with these, which I assume are a case of some sort. Can I actually get this to, like... Can I see my preview here? That would be easier. Yeah. So I guess... I mean, what? Like that? Like that? I don't really know. Again, there aren't really instructions. I'm not sure exactly how this is all intended to go together. Oh, I guess this would probably go here, because there's a switch. And I guess that would go underneath, but this surface isn't conductive, and it's got this I2C cable, which I guess goes to one of the headers on here. But why wouldn't I just use... I'm more confused than ever. I'm more confused than ever. So this has I2C on this end. Black is ground, which makes sense. Ground SDA, SCL. But on this one, it's like source 2, source 3. I don't know. That's not I2C. And that's not I2C. And this is... Okay, I guess this just has a different connector for some reason that I don't understand. And there's this cable bundle from the controller, but I don't know if any of these are double-ended. I guess I'll have to unbundle it to find out. I'm gonna go with no. Probably no. Maybe no. Maybe yes? No. Well, these are probably for video cards then. Yeah. Because that's the primary use case. Controlling the voltage regulator on video cards. Alright. Well, I will plug this in, I suppose. And I have to jump this power supply. Accidentally paused the recording, but whatever, that's fine. So I've jumped the power supply. Now these lights are on. Whoa. Was that an initialization thing? Presumably. Oh, well. It's definitely, yikes, hot, fast. Ah. Okay. Those lights are probably on when it's active. It does have thermistors on each of the zones. They are temperature controllable, as I understand it. So let's plug this thing in and take a look at the software. Okay. Let me just have Jamie here pull that up. EVC d. Oh, so it has a... I don't know what this does. I don't know what any of this does. What did I plug it into? I2C 3 or 1? It's gotta be one or the other. Found 0. Found 0. Elmor, oh. This is the HOT300. I believe. Yes. No. The HOT300B CPU 02. HOT300. Well, it just says HOT300. I have no idea what I'm doing. There's not really a manual for any of this. Not that I can find easily anyway. I plugged it in, right? Oh, wait a second. That's UART. This is UART. Oh. That's something else. That's a UART port. I am blind. There we go. There it is. So, this is monitoring. There we go. Yeah. So it's set to 50 degrees in every zone, and if I just shrink that back down a little, I'd say that that's 50 degrees. It's a bit uncomfortably warm, but not too warm. And that's zone 3 here. So I'll just increase zone 3 to something that is a little more than uncomfortably warm. And hit apply. And it's gonna start climbing. Wow, that is way over 80. I can smell it. Yep, that is quite hot. That is something that would burn you if you touched it for more than a second. It's a little bit concerning to me that it overshot it so much, but well, I guess it makes sense, because, I mean, it's heating up. It's heating up this side of the circuit board, but the thermistor is on this side, and this isn't like, you know, a super dense multi-layer circuit board. So, yeah, I guess it makes sense that it would be a bit delayed. And it's not like it's sensitive electronics either. But, yeah. So it goes up to 102.4 here. And, yeah, you can't type in anything higher. I don't know what would necessitate you putting this at 102.4. I guess I also don't know how decoupled the thermistor temperature would be from, like, the board temperature. Because the point is to reduce your need for insulation. But I guess I'll find out in the future. And I'll let it go back down to 50. Hello. Yeah, and it's trending down. So yeah, that's the HOT300. Slightly terrifying. Other than that, what do I have here? Thermal pads. I would have gotten the thermometer, but it was out of stock, so I've been working on making my own thermometer with an ESP32. That is coming along a little bit poorly because the ESP32 ADC is just not very good. Of course, there is the liquid. Let's not put plastic on top of extremely hot things. In fact, let's turn that off. That doesn't need to be on. Oy. So the liquid nitrogen pot comes with, well, this bracket, of course, which goes on top to hold it in. It comes with some foam, some insulation to insulate it. Comes with this back bracket, which supports, well, you can see 775, 1150, 1200, 1700, Xeon, AMD stuff. And, ooh, yikes. Corruption. It comes with the pot itself, which is very, you know, existent. Would that I could get the $2,000, $10,000 AI generated one, but that's not happening. So yeah, it's a big piece of copper. full of edges to break the Leidenfrost effect so that you can actually transfer, or rather so that you can actually remove, technically speaking, the heat from the copper. And there's just one thing that bothers me. Where's my bracket? Oh, what a mess, what a mess. So you've got, like, this bracket from an HD12. It has these cutouts for the screws in the ILM. So when you go to put it, you know, on here, it lays pretty flush. Screws go in the holes. But when you take this and you do that, just so I can line it up, it doesn't really lay flat. Like, this screw on the bottom pushes it up a lot, which is hard to see on camera, but it's very much not flat. And I feel like with any kind of mounting pressure, that screw is going to push in. I don't understand why they don't have holes cut in this to compensate for that. I mean, I can do that myself. I mean, this isn't really, like I said, this is a two-sided PCB, and it just has wires going around the outside. There's nothing in here. You can drill through this just fine. I just don't know why they wouldn't include that. I mean, unless they just think it doesn't matter, but it's not pleasing to me. Plus, you would need really thick thermal pads on that other side. And we know that thick thermal pads are bad. But that's it, really. That's my Elmor Labs haul. I already did some overclocking on air with this board and this processor, a 6600K. And I'll be moving to dry ice and then liquid nitrogen in the near future, which will also be on this channel. Hope you enjoy somehow.